Uh, Good afternoon, my dear grade 9 learners. Today I'm going to present to you surface area of right prisms, and focus will be on a cube as well as rectangular prism. And my name is Mofokeng L, subject advisor for maths grade 8 and 9. Right, so let's have a look at this. As I've alluded, we are going to look into the surface area of a cube and a rectangular prism. Now, if we are talking about the surface area of a right prism is the sum of the areas of each individual face that makes up the surface of the prism. And then the prism is a 3D shape with two identical parallel faces at the opposite ends. Let me repeat this one. A prism is a 3D shape with two identical parallel faces at the opposite ends. If you take the actual object, we are referring to it as 3D object because you can be able to touch it. But with 3D shapes, we only see the shape of a 3D in the form of 2D. That is why we are referring to them as shapes, right? But having said that, let's have a look at the issue of the two identical faces. If you take a cube will have all the identical sides with a identical area. So that simply means with a cube you can't be able to see it because all the faces are identical. But the key thing is, if we make reference with the two opposite faces, the two opposite faces that are identical, we refer to them as the basis of that particular prism. So for each and every prism that is having two identical parallel faces at the opposite ends, those parallel faces are referred to as bases. Right, so these faces are known as the bases, as I've indicated also. They are known as bases of the prisms. And then let's have a look at this one. If these two faces are square, it implies that the right prism is a cube, but not always, because we can have a rectangular prism with a square basis. So not all the prism will have will not have a square faces. So it might happen that a rectangular prism has a square basis, right? But with a square, with a cube, we will have all the faces being equal, and if we take two of them, it becomes our basis, right? And then considering a rectangular prism, if these two faces are rectangle, the right prism is a rectangular prism or a cuboid. And again, I've indicated that it might happen that a rectangular prism have two opposite faces that are a cube, and that will not necessarily mean it is a cube, right? And then if we go on, The focus today will be on a cube as well as a cuboid, which is the rectangular prism, and then we are going to calculate the surface area of a cube. We are going to calculate the surface area of a cuboid. Right, if we consider the surface area of a cube, we will have 6 faces, and these 6 faces will have identical areas. So each face will have area of s squared. Because we are having 6 faces, that means we will have 6 faces of area of s squared. The first one, it is this face which is on top of the cube. This will be the face that is seen in front of the cube, or let me say this one will be the back one. This will be the back face, and then we will have this face that is on the left hand side of the cube, and then we also have this which is at the bottom of the cube. We also have this face which is on the right hand side of the cube, and then we have the last face which is at the back of the cube. So these are the faces of the cube with equal areas. So there we go, it is 6s squared, that is the surface area of a cube. Right, let's have a look at this example. A cube with one side equal to 8 cm is given, and we need to calculate the surface area of this cube. So the starting point will be the formula that we will be using to calculate the surface area for a cube. Right, here we go. The surface area for a cube is 6s squared, because we have areas of s squared, 6 areas of s squared in a cube. So what we need to do now, we have to actually substitute the side length of a cube, which is 8. In this case, we are going to substitute s with 8, not 8 centimeters. I will indicate why I'm actually saying that. So we are having 6 multiplied by 8 squared, and 6 multiplied by 8 squared will give us 6 multiplied by 64, which will give us 384 centimeter squared. Now let's have a look at what I've said when I was saying don't use the units with the calculations. Only use the units when you write the final answer, because the problem is one: if you use the units, there are learners who are actually substituting wrongly, whereby they will be having 8 centimeter squared. And if it is 8 centimeter squared, it simply means 8, it is not squared, and it's supposed to be squared. So you only square the unit, and it changed the answer now. That means the answer that we are going to have, it will be the answer of 6 multiplied by 8. So if you decide to use the units with your calculations, ensure that you substitute correctly, ensure that you substitute using the brackets. So other than that, I would encourage you that you don't use the units during the calculation, but you indicate the units during the last step, which will be the answer. Right, so let's move forward. We are now going to look into the surface area of a rectangular prism. Right, for rectangular prism, we are having the face that is comprising of length and breadth. So in other words, when you multiply length and breadth, you get a particular face, of which this face of length times breadth will be 2. It will be the front face as well as the back face. The back face as well as the front face. And then we're also going to have the face of the area length times breadth. So length times breadth, it will be the top uh, face as well as the bottom face. And then lastly, we are going to have the face breadth times height. Breadth times height, we will have one on the left hand side and the other on the right hand side. Hence, what you see here, it is the net of the rectangular prism with those 6 faces. Right, so now let's have a look at what we need to do when we calculate the surface area of a rectangular prism or a cuboid. We will start by having surface area being equals to total areas of faces. Total areas of faces, we are having 1, 2, 3, 4, 5, 6, of which not two of them, of which each of them appear twice. Hence the formula, we are having the area of length times breadth. How many of them? 2. We are having area of breadth times height. How many of them? 2. We are having length times height. How many of them? Also 2. And then we have to substitute from this formula. Right. Let me also indicate that this formula, it is simplified by taking out the highest common factor. So in this case, 2 is the highest common factor, so we have just simplified it. You can use either this formula or the original formula. Right, let's use the original one for this activity. Calculate the surface area of a rectangular prism given alongside. Right, we are having the side length of 10, the breadth of 4, as well as the height of 6. So we will substitute from this formula, and then as we substitute, you will see that length is 10, breadth is 4, and height is 6. So we have just substituted everything there, and then we just simplify, and then after simplifying, we get the answer, which is 408 centimeters squared. As I've indicated from the previous one to say, don't use the units during the calculations, because some of the learners, they don't substitute correctly and it affects their solution, and ultimately they don't get the full marks. So it is best to only use the values, and then at the final answer, that's where you will have to indicate the unit. I hope you actually uh, pro, uh, profited from this lesson, and thanks for tuning in, my dear grade 9 learners. We will actually meet again during the next lesson. Thank you very much.